A quaternion is a variable with 4 numbers, x, y, z, and w. Now, this is just a convenient way of representing a 3-dimensional angle. Now, I know some of you would love for me to go into complete detail on how they work, and I know that because that's pretty much how I am, and it probably relates to imposter syndrome, so that's kind of the main reason I'm avoiding that right now, and I really want to just demystify quaternions for us. Whenever you rotate an object, you do it based off of its anchor point, which is its position. Now, most of you know this, so I'm not going to go too into detail. The main battle we have with quaternions is usually when you have a specific angle in your game, such as your player's rotation, and you want to add onto it, but you can't. You have to multiply it because adding doesn't work for quaternions. But when you multiply it, you find out it makes no sense, and you just have to give up because it's just dumb. So you're kind of just struggling. And you find a YouTube video, it makes you change the rotation to a vector 3, then you add to your vector 3, and then you turn that back into a rotation. This feels really clunky, and it just kind of sucks. So maybe we could try to figure out something as well on how to do that more comfortably. Let's start off by multiplying two quaternions, and from now on, I'm going to start saying angle because I don't like saying quaternion every single time. Anyways, let's get a basic understanding of how to multiply two angles. So here I'm multiplying the two x's together and the other two variables are 0. And the reason it rotates in the same direction is because our imaginary red line here is actually our local x-axis rotation. I'm not sure the best way to describe it, but basically we rotate along this line. Replaying this experiment along the y rotation gives us the same result as if we just rotated the object by its y. The reason is because our y local rotation, which is this yellow bar, isn't really moving, it's just rotating in a circle and keeping its same anchor point. But what happens if we multiply by multiple axes? Let's say we multiplied an existing y rotation to an x or a z. In this situation, it's pretty much the same thing as well. It rotates along its red axis, which is the local axis, but it's also our world axis. All that to say that multiplying and adding this rotation is pretty much the exact same thing, and it also goes for the z. So multiplying an x value or a z value to an existing y rotation pretty much doesn't do anything. This is the same as if you just added the rotation instead of just multiplying it. Anyways, this is pretty much just rotating the object inherently. And the reason I'm saying pretty much so much is because it's good enough for now. Like, I just want to make games, and you probably have that feeling too. So what's the point of getting into the whole mathematical equations of quaternions when we could just use them for our game and not completely understand it just yet? Quaternions are only really complicated because they add way more than just one rotation. It's usually multiple. So even though we're multiplying by a y and an x in this situation, it still pretty much does nothing. It's the same as adding it, but it's not always going to be like that, it just is for now. So in this situation, multiplying it is basically the same as adding it, and I just want to show you here that changing the x rotation or the z rotation is the exact same thing, at least visually for us. Now, if we have a more complicated rotation like a 45 on x and 45 on z, if you rotate by the y, it rotates on its anchor point. Now, rather than adding rotation, let's go into multiplying it. As you'll notice, once I start moving it, of course, the yellow bar is its local y rotation. The way you can think of this local y rotation is basically just which way is up for the object. If you multiply a quaternion by a y rotation, it's going to rotate along this axis. That axis is basically showing us what side is up. And when we multiply a quaternion by a y rotation, we're rotating it based on relatively what is up for that object. And this is the same case with z and x axis. We're going to be rotating along our local z axis, and when we multiply by an x rotation, we're going to be rotating by our local x axis. And that's pretty much what multiplying a rotation does. It just rotates us along our local axis. Now, some of you might have noticed I had an added rotation variable. That's pretty much just a vector 3 that gets added to our base rotation before turning it into a quaternion / a rotation. This is the issue we had earlier where we have to turn our rotation into a vector 3 and then turn it back to a rotation. This does it in just one step. It just adds it before we turn into an actual rotation. Now, adding a rotation is something that happens all the time. You just add a rotation to spin around your anchor point, but relatively to a game development sense, this just means you're rotating your character left and right. And this is the most practical way of using the y rotation. Multiplying a y rotation, on the other hand, actually does something very weird. it rotates your head left and right. Now, this is actually very practical in some games like Rust, because you want to look around looking for enemies while you're still running forward relative to your body. So that's just one way of using it. The reason I want to demystify Quaternions is because personally, I just want to learn more and it sounds like a lot of fun. But I want to do it in a game development sense, and that is making a planet where you're moving along with the planet and your camera follows it. Now, before you think that this is super complicated, it's actually not that bad. Here's all of the code that I wrote for this little project, and most of it is really just for moving the player and keeping him attached to the actual planet. Just to go over the movement portion of our code, first I save our world position into a local position relative to the planet. Next, I move on to rotating the planet automatically so I don't have to do that anymore. The next step is to get our velocity, which just involves getting our new position and subtracting our old position. To get our new position, we just change that local point that we saved earlier into a world position, which all of that is nicely being handled by parent.transformPoint. Once you add your velocity at the end, you get this nice rotating ball along a planet. Now that the player moves along the ball, we have to make him actually rotate along relatively to the ball as well. I want to be a little transparent here. I did have to do a lot of testing on my own to get to the final solution. Even though the code was only a single line I had to add, it was still a little complicated to get there, and so I want to share the progress I made into finding out that line of code. My first big idea was adding the North Pole. I don't know why, and it really didn't end up helping, but it looks kind of cool. Also, up to this point, I haven't put a first-person perspective from the character's point of view. That's because it wasn't working, but I just set the transform rotation equal to our planet rotation. Ignore the multiplication, that was just some testing. But yeah, setting our rotation to the planet's rotation just made it simple. Now that we have our player rotating with the planet, it should be a lot easier to get him rotating relative to our body, right? Yes, it actually is. This is an editor note. I just realized I made a really dumb mistake when I was programming, but yeah, just multiplying the rotations that you want to have relative is just as simple as multiplying a quaternion based off of your player's rotation. One more side note really quick. The player rotation I'm talking about is our desired rotation, so basically what we input into the game to make our player rotate. That's pretty much it. That's all I have for this. Quaternions can be more complicated than this, and there's a lot more use cases that I obviously have not gone over. But if you do want to move the player relative to some object he's either standing on or that he's a part of, like this planet, then you can have that possibility now. If you thought you were just gonna get away with watching a video, you're completely wrong. You better go program, because you're not gonna understand it completely unless you do. Watching a video is always easier. It's always easier no matter what. Just go do it yourself right now. Program, please.